Hello, and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronics supply chain fields. I'm Chelsey Drysdale, Chief Content Officer of PCEA, and I'm joined by Mike Buteau, President of PCEA. We hear a lot these days about smart manufacturing. Every time I see the term, however, I have to wonder whether there is broad consensus on what it means, and more specifically, its application in electronics assembly. With us today to help shed some light on that is Brian Morrison, Vice President of Engineering for Vexos, a mid-tier multinational EMS with manufacturing facilities in the US, Canada, China, and Vietnam, and more than 900 employees worldwide. Brian, thank you so much for joining us on PCB Chat today.
You're very welcome. I'm glad to be here.
Let's get this out of the way first. How do you define smart manufacturing?
Well, in my eyes, smart manufacturing is essentially a methodology that leverages equipment, software, and integration protocols that allows continuous feedback to the process. To me, basically, it's the ability for us to use equipment and data to have owners basically act, react, execute, and adjust non-value added activities and optimize production. For me, in order for something to be smart, the process must be defined with targets, the means to monitor, report, detect nonconformities, and then be able to make adjustments based on those data.
If one views smart manufacturing as automation and computer systems to detect deviations from the norm, what are assemblers doing in this regard beyond what is available off the shelf?
Well, I think what you'll hear a lot is a lot of AIs, and everyone's coming out of the cloud and they're saying data management and there's more data. I think as we get more intelligent with the equipment that we have, the more data that's available. The ability for you to use that data to actually make judgments based on that is actually critical. A lot of normalization of the data. I know the manufacturers are coming up with CAMX and IPC standards to be able to communicate between equipment and softwares to make that available. I think the real differentiations between what's considered a smart manufacturing facility and something else is the ability to use that data and make adjustments to your manufacturing. And I think that's what a lot of people are doing nowadays. Integration, software, decision-making, upstream and downstream feedback.
So Brian, following up on that then, that becomes really part of your IP, right? You know, the ability of an individual company to not just collect that data, which everyone's doing, but then how you process that data and put it into action would really be kind of part of your IP.
Yeah, that's absolutely correct. And the thing is that it's becoming easier and easier for manufacturers now that equipment and software is becoming smarter. I think the more challenging one is manufacturers nowadays have a mix of older and newer technology. So being able to use all those different inputs to basically go in, you're absolutely right, requires IP coordination with the manufacturers and software providers to do that. I've been on a number of calls where I've had competitors on the line in order to basically have them work together in order to create that IP and to make a manufacturing solution that makes us competitive. And the results are outstanding to the point where we have equipment's talking to each other, is knowing what's going on, and be able to react whenever something's needed.
Does that conversation tend to get initiated by the assembler, or does that tend to come from the equipment manufacturer, the software supplier, who recognizes a similar problem across multiple, or maybe several of their customers?
Well, I've never seen where another equipment manufacturer's reached out to another one, although it is rare. A lot of the integrations where everyone's trying to get onto the same platform as of late, but typically it comes from the manufacturer. I have a need. I need equipment A to talk to equipment B. They don't have an interface available. This one has output D that doesn't work with C. How do we make those work? So I think a lot of it is a collaboration from the assembler, bringing the parties together, coming to a mutual agreement. And commonplace, what will happen is the IP that we generate, the manufacturer of the software will see the value in that because other assemblers have asked the same thing. And we'll work together to basically provide that level of smart integration, and they'll actually sell it to the next customer, and it just becomes a great working relationship.
How do you balance the cost of implementation of additional software or machines with the cost of operators and the annual volume of product being built? For smaller run production, is smart manufacturing even feasible?
Well, yeah, I guess it all comes down to the fact that it all starts with a value stream mapping, right? You got to take a look at your current process. How are you doing it? Where are the areas of improvement in productivity as relates to quality, cost, waste, etc.? Really, those are lean elements that basically drive where the opportunities are. From there, what you basically need to do is we take a look and we say, okay, what are the solutions? And usually that's software or equipment, which could be capital. It could be someone's time to basically go from there and to make those ones, or it could be operators. How do I eliminate high cost operators in a high cost region? Do I put robots in place to do that? So I think from a cost of implementation versus this, it's a cost versus benefit. And what we typically do is we look at decisions like what's the addition of the cost, but in addition to that, what is the risk? What's the timeline? What are the resources? And what's my benefit? Tier one on the smaller runs versus larger. Whenever when someone thinks automation, they think of automotive, single SKUs, millions and millions of these things, optimized all day. But actually, it's the small manufacturers. We're a high mix, low volume. In some cases, we do a lot of prototype. And automation and smart manufacturing, if you don't do it, you're not competitive. You basically need to make sure that you are leveraging all of your changes, looking at your changeover, all of these, and being able to collect all the data where you may not run a product for 6 months to be able to find out what you did here and what the next one was 6 months ago to determine did you make an improvement, did you not, in order to make a decision for the next corrective action and go from there. So having that data and being able to look historically to make decisions in the future are really important. And that could be low cost. That could just be simply software. It could be MES. It could be data collection. It just be connecting to equipment. So it doesn't have to be costly in order to get the benefits.
I'm going to take a moment to mention our sponsor, PCB West, the leading conference and exhibition for printed circuit and design engineering, coming October 4th to the 7th to the Santa Clara, California Convention Center. Learn more at pcbwest.com.
Brian, we've heard a lot over the past few years of the so-called digital twin, which is basically a virtual model designed to accurately reflect the physical version of that same object. How much of smart manufacturing is tied to the use of the digital twin?
Well, I think one of the things that we embrace, or essentially a digital twin from our perspective, is what we call the essence of DFX, or what we used to call virtual prototyping, or using models to make decisions. The ability to transform virtual data into a physical model that we can actually perform analysis on. We usually will look at it for assembly, test, fit. We'll use softwares and mechanical, what we call ECAD and MCAD, to basically take a look at those models and find the opportunities as it relates to design rule checks, and then make decisions on what we should do for the new product introductions. I think a key factor of using this digital is really what helps us make and our customers make good decisions on what changes they should make before we actually even order a single part or release a single PCB or place a part onto the board. So it's really differentiation, and it costs no money, and it allows us to integrate at the time where they can make change.
Do smart manufacturing and lean manufacturing intersect? And if so, where and how?
Well, I think the elements of lean is really what drives us to smart. So I think a lot of people look to smart just because the elements of waste within lean basically drives that. You look at your process, you actually look at where your elements of waste are, and then you typically apply smart means to basically either address that through an optimal solution, either through equipment or software. So I think they're, in my mind, they're analogous. In terms of one leads into the other.
So, how do we use the tools available today to reduce defects that are inadvertently designed in? For instance, tombstoning can be the result of surface tension imbalance due to unequal lands, or perhaps it can be caused by mounting passive parts over a via, whereby the pad with the via heats faster due to the lower thermal mass. Are these issues best addressed in the DFM rules, or does smart manufacturing have a role to play?
So I think one of the things that we essentially do is identifying the opportunities and risk in manufacturers. We talked a little bit about the digital twin. So being able to predict the risks of the product, identifying where potentially problems may occur. DFM is an element, but also there's supply chain risk, what are discontinued end of life, not recommended. There's elements of the land pattern, as you've alluded to, the vias and pads and clearance, as well as the test access and other strategies in order to do improvement. So by actually going through that risk and determining kind of where we are, and then running it through manufacturing, using the smart information to actually determine whether our predicted units actually have a problem or not, and then validating that, making corrective action, and then integrating that as part of our continuous improvement.
If you think of smart manufacturing as something of a spectrum, right, where we're somewhere between the embryonic stage and fully mature, where is the electronics assembly industry on that spectrum right now?
I'm actually pretty optimistic on where we're going. I'm actually very encouraged with what equipment manufacturers and software manufacturers are doing to basically bridge the gap, which wasn't there before. Manufacturers' equipment didn't want to talk to one another. And I think nowadays they've realized that talking to one another is the essence of us being competitive and being able to move the industry forward. So I would say we're more close to sustainability, almost mature on the upper echelon, at least where we were from probably about 10 to 20 years ago. I think we're almost there. I think it's going to take a while for people to take on. People are still a little bit hesitant to jump on board, but I think we're almost there.
Thank you, Brian. Our guest today has been Brian Morrison of Vexos, and our sponsor has been PCB West, the leading conference and exhibition for printed circuit and design engineering, coming October 4th to the 7th to the Santa Clara, California Convention Center. Learn more at PCBWest.com. For PCB Chat, this is Chelsey Drysdale. Have a nice day.